Today I'm going to talk about 9 ways to do inheritance in Rust, a language without inheritance. I'm Carl Kadie. All the code is in GitHub, and the link is called Inherit. I'll put it on the Discord also. So first things, what do we mean by inheritance? Uh, if we're doing an object-oriented, class-based language, then we say a subtype can inherit stuff from a supertype, and the kind of stuff it can inherit is an interface. An interface, well, when two types implement the same interface, that means that we can use either one at a function that requires that interface, so they're substitutable. Another thing that a subtype can get from a supertype is code. If the supertype implements something, then the subtype will be able to call it. And finally, in some cases, if the supertype has fields, then the subtype will also inherit those fields. So Rust doesn't have class inheritance. That's certainly true, but it does have tools to get us the effects of the first two. It has shared interfaces and it has shared behavior. And we're going to look at those tools.
Is anyone else in the meeting? Because I can't see Carl's screen on it.
I am in the meeting and I see Carl, but I also don't see your screen, Carl.
Okay,
that is a good point.
Make one more attempt.
I will see.
Start sharing. Share.
That looks better.
Okay.
Yep. Yeah, that's it.
Let me go over some definitions because I'm going to be a little loose with vocabulary. When I say interface, if you're familiar with languages like C#, that's equivalent to what C++ calls an abstract class. Those are roughly equivalent to what Rust calls a trait. And in all these cases, it's an interface, an abstract class. A trait is a contract or a role. It's not a struct or an enum that you can actually have a value for. A concrete class corresponds roughly to what Rust calls a struct or an enum. And this is a concrete type. It's something you can create and have values of. Hopefully that'll be made a little more clear at the end, or you just have to play with it to get these concepts in your head. My credentials. I've programmed professionally in C++ and in C#. I've programmed in Python, which normally wouldn't be a credential for this, but I programmed in Python with lots of classes. And my greatest claim to fame here is that I took a class in Smalltalk, one of the kind of most famous object-oriented languages, and I took it from Ralph Johnson, one of the authors of the Gang of Four design patterns book. So I should know what I'm talking about. We'll see. The format of this is that I'm going to have 9 puzzles, things that you might come across when you're programming in Rust that you need to solve. I'll present them first from a class point of view, and then we'll see code in Rust that will solve them. Discussion is welcome. I think I'm going to say I don't care if we don't get through all the slides. I'll just have a part 2 or whatever later. The one exception to that is I don't want us to try to define what object-oriented really means. It's too controversial. So here's the first problem we have. This is from a crate I have called range set blaze. So range set blaze is a data structure that holds, that represents sets of integers like U8s. For it to do that, it needs, but it can work with different kinds of integers, so an I16 or whatever. For it to do that, it needs to be able to manipulate the integers, so it needs them to have functions like give me your min value, give me your max value. There's one it wants called create an exhausted range for this integer type. So if we look at that problem from an object-oriented point of view, we might create a class diagram like this, with an abstract type integer that requires every integer thing to have a min value method, a max value method, and then maybe given those, it can define the exhausted range method for everybody who inherits from it. And then things that might inherit from it would be like our U8 integer, a concrete class, and it has to make sure it has UA or min, max, and then it'll get exhausted range for free. And likewise for I16. So a quick question to the room, how would we make this happen in Rust? You can just yell out. Traits. And how do we get the exhausted range so we only implement it once?
Default implementation. Of the trait.
Default implementation. Just so. So we have a trait, we call it integer. We say an integer trait has to implement min value and max value, and it also has to implement exhausted range, but we'll actually give a default implementation. So you don't really have to implement exhausted range. You can get it for free. And then after that, we'll say to implement the integer trait for U8s, here's what you do. And you have a definition of the min value for a U8 and the max value for the U8. We don't have to do exhausted range. For I16, looks the same. And now we can use it. We can make R1 equal to an exhausted range of U8s, R2 an exhausted range of I16s, and then we can verify that R1 is equal to this this range that goes from 255 to 0 inclusive, which is the way Rust has ranges that don't have any values inside the range, empty ranges. And in fact, there's a method called empty range on ranges, and we can verify that R2 is indeed an empty range. So again, that's the trait default method. Good. Okay, I've got another crate called Device Envoy that helps simplify working with microcontrollers. One thing it wants to manipulate are servos. Servos are electric motors that you can say what angle you want the motor to turn to. So we want to be able to write programs that just use generic servos. And so what do we want those servos to do? Well, a servo has to have a set degrees method, maybe some other methods. And for our particular microcontroller, say our ESP32 family, we'll want a concrete type servo ESP that actually has a specific implementation of set degrees. But we also have this notion of a servo player, which is also abstract. And a servo player needs to be a servo, but it has additional methods. So say it has an animate method where we can move to a certain angle, wait an amount of time, move to another angle, wait a certain amount of time, and then maybe loop back and forth, animate. And then we'll have a different concrete class for that, servo player ESP, that will should do both those methods. So to the room, what's the concept that lets us set things up like this in Rust? Connor?
I mean, you could make servo player a trait that also requires you to implement servo.
Yes, so let's, whoops, I should probably move the microphone over to here. So that's super traits. So we'll have a trait servo that requires that we have set degrees. We'll have another trait called servo player that requires that we do everything that servo does. And it has this additional requirement that we implement animate. Now we can have, I've got a little kind of mocked up here, servo ESP. So it'll implement the servo interface for servo ESP. And in this case, I'm not really going to do hardware. I'm just going to print out a message. This actually surprised me when I was making this. I forgot how it worked. So servo player ESP is also a concrete thing that it needs to implement both servo and servo player interfaces. I'd forgotten that we need to have two different implementation segments here of code. So you say, here's how we implement servo for for servo player ESP, set degrees does this, and here's how we implement animate. And here's some things that we'll pretend we're going through steps. Once we have that, we can write programs that are generic that work for any kind of servo. So center servo works with any kind of servo, and it sets the degrees to 90. runwave works with any kind of servo player, and it calls the player.animate method on a particular set of times, angles and times. And once we've set this up, we can get what we want. We can say servo ESP lowercase is an instance of servo ESP, servo player ESP lowercase is an instance of servo player default, and now we can call center servo on servo ESP, but we can also call it in servo player ESP, and we can call runwave on servo player ESP. What we can't do is call servo runwave on the regular servo ESP because it doesn't know how to do the animate. So good, we got that fancy diagram before, and now we've got it all in Rust. I should say we won't get to anything tricky till 5. This is just trying to understand every which way I could think of to do inheritance-like things in Rust. Problem 3, I think people will know this one. We want to add a new method, isOdd, but we want to add it to an existing type that's outside of our control usize. So how do we do that?
Implement a new trait for usize.
Yes, which we call just by convention,
Extension.
which we call by convention an extension trait. So if we think of this in terms of object-orientedness, we'll have an abstract class, usize extensions, that requires isOdd function to be defined, and then somehow we'll make usize be an instance of that. That's the only tricky thing, right? It's like this type already exists. How can we make it a subtype of some supertype that we've just defined ourselves? So let's see how to do that. Let me start by saying what doesn't work. If you don't, you would think that maybe you could just say, implement on usize a function called isOdd, and you will get a compiler error that says you're not allowed to implement things on foreign types. In this case, it'll call it a primitive type. But you make this new trait, you say it's got the isOdd, and now the Rust compiler is perfectly happy for you to implement the usize extensions trait on usize and give it a concrete method definition there. So this is extension traits. And when we do that, we can say create a count of 7, and we can assert that count is odd and that it's not the case that 12 is odd. And that all works. One that's hopefully not too hard, I wouldn't think. We have an enum called LED level that has 2 values, on and off. We would like it to have a default value. We'd like it to be able to print debug strings. We'd like to be able to check the equality between 2 of them. We'd like to be able to put it into one of the standard hash tables. We'd like it to be clonable and copyable. How can we do that? You can just yell out. You could go through and implement all these traits. What's the most convenient way to do that? Yeah, so the most convenient way to do that, here's our enum, is to use this derive attribute. And that's giving us all this inheritance, what I think of as inheritance for free, derive, clone, copy, and so on. And once we've done that, it's got definitions. We can say LED default is our default level, on, off. We can check that the default level is off. We can check that on is not equal to off. For some reason, we've probably without really intending it, but we've decided that off is greater than on, and we can do some copying and cloning.
Question, Carl.
Yes, Brad.
Why do you think of derive, clone, copy, debug, etc. as inheritance? Can you expand on that a little?
Well, look at this slide. If you were coming from C++ and said, I want this thing to be a mix-in of all these types, I want it to be a mix-in of the hashable supertype, then this is the way you would think about it. I think it's a good point, though, that just because maybe I have a tendency to think of things in terms of these hierarchies because of my background, that we'll start to notice that the Rust way of doing things not only doesn't have the hierarchies, but it's really only using a few building blocks. Like we called it, 2 examples back, we called it trait extensions, but we never used the word extension. As far as the compiler is concerned, that was just a trait. It's only by convention or by our convenience that we give it the name. It's no different than any other trait as far as the Rust compiler is concerned, which is nice. It means there's a few basic concepts here that are actually doing quite a bit of work, and maybe it'll make it easier to remember how to use it. Maybe you won't really have to remember 9 cases. Okay, this one I'm kind of proud of. We want HTML buffer to feel like a string for a lot of everyday method calls, but we still want it to be its own type. The trick here is that string is a concrete type with storage. It's not an abstract class interface, whatever. How can we have HTML buffer inherit from string type when string is a concrete class?
You're gonna start a fight.
I said how, not should. I said how, not should. Yes.
Have a function that returns one. There's some distinct traits that.
Yes. We were going to see one of those traits. So yeah, Benny?
It's deref, right?
Yes, that's the one I'm going to show. I'm going to show deref. There's some other ones we'll list at the end. So this might be an evil thing to do, but it's really cool that you can do it, even if it's evil. So here's what you'd want to do. You'd want to say, oh, implement string for HTML buffer. And it's going to say, hey, string's a struct, not a trait. You can't do that. That's an error. So there's these traits called deref and deref mutable. And now we create an HTML buffer struct that has one field that's field 0 of type string. That's just the syntax we can use there. So far we haven't done everything here. Everyone will agree is something you should be doing. So HTML buffer now contains a string, and we're going to give it some of its own methods. We're going to say it's got a new method, and here's how we do the new method. Everyone thinks that's cool. Now we're going to implement this deref trait for HTML buffer, and we're going to say it's got a target type of string, and whenever you need to are asked to deref a reference to this HTML buffer, return the stuff at field 0, return the string itself, and likewise do the same thing for the mutable one. And now look what we can do. We can say page is a new HTML buffer page, and now we can say page dot push string, and we can just call the string method on our HTML buffer and push a string in there. And we can do it twice, and we can ask for its length. And we never define length. The reason length is there is because it's defined on string. You can't do everything. I don't think you can test equality directly, but you can put an asterisk in front of your variable, and that's asking for the thing that page points to, and then you can put an ampersand in front of that, and that's say borrow the thing that you point to, and now you'll get the thing itself. Everyone agrees that deref is very good when it's used with smart pointers. So it's used with box and RC and arc and so on. I don't think there's any controversy there. It's probably not a good idea to use it this way here, because the whole reason I wanted to create an HTML buffer instead of a string, because I could have just used string as a string type as my HTML buffer. The whole reason I gave it a new type was that if I got mixed up and put in the wrong thing, I would get a compiler error. And now I'm not going to get a compiler error in a lot of cases because I've made it I've made it so permissive. There are some other traits that work in similar but not identical ways. If this is of interest to you, so you could look at the adsref trait, the from trait, and the borrow trait. All do things that are a little bit similar to this. Puzzle 6. So range set blaze will hold a set of integers. We might have a whole collection of these sets and want to be able to do a union of them, like a vector of range set blazes, and we want to do the union of all of them, or an array of them. if we look at that in terms of object-orientedness, we'd say, okay, a collection, we're going to call that an abstract class called iterable. A collection, I didn't quite write it down here right, but say it's a collection of, range sets specifically. Well, that'll be iterable. I should say it only knows about range sets. I forgot to do that. And it knows how to do a union if we're given like 7 of these in a list, how to do the union. That's still abstract. But specifically, if we have a vector of range set of range sets, then we can get the union, or an array. That's all fine. That we could just do with the extension traits that we saw before. But we want it to work with any kind of collection, any, we'll say, iterable thing if we're doing this in Rust. How can we make it work with any iterable, even ones we haven't anticipated? Keywords?
Type erasure.
What's that?
Type erasure.
Type erasure.
Type erasure. Maybe, I don't know. That's not the term I was looking for. So I'm going to look for the term a blanket implementation way down there. We'll see if that's the right term. So let's set this up first. I don't really want to bring in my whole range set Blaze data structure. So we're going to make it so the only integer it knows about is U64s, and that it's really just a B tree set. We'll mock it up for this. And it knows how to create a new range set Blaze, and we'll know how to create that's empty. We'll know how to get one from just a list of integers. We'll call that from slice. And we'll tell it how to do the union of 2 range set Blazes, exactly 2. And we do that by going, in this case, going back to the B tree sets and doing the union and then collecting it all together. Oh, and we'll have a predicate, a function that returns a bool. Is it empty or not? So that's all set up. The next thing we can do is set up basically the same kind of extension trait we did before with a super trait. We can say we're going to define a trait range set collection. It's going to provide an implementation of union, but it requires that whatever it's being applied to can also do everything that into iter does, which is another type that says you can convert something into an iterator, and specifically an into iter of range set Blaze. So if we do all this, then we could do range set extensions to like vector and array, and we could, for an array of these or a vector of these, we could do union. But we want to do more than that. We want it to work for every kind of collectional thing, every iterable thing, even ones we haven't anticipated. And the way we do that is what I'll call a blanket implementation. And the syntax is that we want to implement range set collection on a generic I, where I is anything that already implements the into iter with an item that's a reference to a range set Blaze. And we'll see what you can do with that. So first we'll create 3 range set Blazes, A, B, and C, and then we'll, just so we can check our work, we'll have anticipated what the union of A, B, and C should be. And then if you look at the next one, we can take a vector of A, B, and C, vector, and then say dot union on it, and we will get the range set Blaze that is the union, and we can see that it's equal to expected, as expected. So that's good. And it works with an array, but it can even work with what I would consider strange iterators. So I was surprised when I found out that the Rust option object can be iterated. So we can create a sum of A, and then we can ask to iterate through all its values, which will only be 1. And anything that we iterate, we can filter, and then we can do some test to see whether we would like this or not. And even though this is a really weird type, it's a filter of an option, we can still call .union on it, and it'll compile because we did this blanket implementation. Here's one that I faced in range set Blaze. I wanted to treat all 15 integer-like things uniformly. So that's what I'll call the numeric integers, U8, U size up to I128, but also the Unicode characters and the 2 IP address types. So for all these, because I want to be able to keep them in my set thing, I want to be able to maybe get the min and the max, and maybe I need to be able to add one to an integer or an integer-like thing. So in terms of a class diagram, we'd say we have an abstract integer, and then we have some kind of numeric integers. And for those, we have a way that we know about to add one and get a min value and a max value. And we also have Internet Protocol address integers, and maybe they have a different way than the numeric ones for adding one and for getting the min and the max, but maybe in common with themselves. And the Unicode characters will be off by themselves. And then we have specific concrete classes that would implement each of these. So if you had to do this, if you wanted to define these 3 methods on all 15 classes, what would you do?
Enum at outer level.
So the one idea is to use an enum. The thing here is we need to work with these existing types. These are all system types, so we can't create our own type that's U8, U16, and enum. Any other suggestions? Yeah.
Reluctantly, macros.
Sorry.
Macros?
Macros is what I'm going to use. I'm not confident now that it's the best solution, but it is the one I really used, and we'll talk about why I used it. So I'm going to use macros as suggested. So we have a trait, integer. It's got to be able to add one, min value, and max value. And now with macros, you can do anything, right? So I'm going to make a macros just for my numeric types. And for that one, it'll say, oh, you can add one by just adding one. There's a constant called min. There's a constant called max. So that's how we get our min and max value. That looks pretty good. For the IPs, we're going to pass in 2 types to the macro, the IP type and also its numeric representation type. And the way we add one is we convert it to its numeric representation, add one numerically, and then convert back to our P type. Likewise, and then for min, since we know it's numerical representation, we can ask the numerical representation's min type and convert that into the IP type. So we're set. I don't know, since there's only one character type I'm working with, I needed to make a macro, but I did anyway. For Unicode characters, adding one is particularly tricky. We convert it to its numerical representation type, which is a U32. We add one, but there's this range of U32s that aren't in the middle of Unicode that aren't allowed to be used. So if we find ourselves at the edge of that illegal, invalid range, then we skip over it and then convert whatever back into character. And then actually min value and max value are similar to the numeric, because unlike the IP types, character does have the min and max constants defined. And then we just do a whole bunch, we do 15 implements calling our macro. And there's a lot of different ways that you could arrange with macros. You could have had, anyway. And this is fine. And this is what I do in range set Blaze. So the question is, isn't there some trait that all these types already have? And the answer to that is no, but all 12 of the numeric ones do have a trait in a third-party crate called num traits, called primint, primitive integer. So why didn't I just use num traits primitive integer, and then I wouldn't have to do this macro stuff. I could just do an extension on primitive integer. And does anyone know why that doesn't work? So there's a problem with coherence, and specifically because the num traits crate is external to me, I don't know that in the future they're not going to add Unicode characters to it. And that means that if I've got an implementation for the numeric integers and say the character integer, and they're distinct. But in the future, who's ever controlling my definition of this primitive integer could put my character in there. And now we've got overlapping classes, which Rust doesn't like. Having said that, I could have just created my own primint type and just had 15 lines assigning it. And it would be about the same amount of code as using macros. So I don't know that using macros is better or worse than that. They're about the same amount of code. The thing I like about macros is when the going gets rough, you can always just use a macro. Just to show that this works, if X is the U8 254, then we can add 1, 255. If it's the Unicode character A, we can add 1. That's normally not allowed. I mean, add 1 isn't something you normally can do with characters, but we can do that now. And we can get the min value of characters, something that was defined, but we can also get the min values of the IP addresses, which there's no constant that defines those in the standard library, and now we've got it. Okay. Here's one that I didn't know you could do. So I've got this output array, and it's an array of Booleans of fixed length. So abstractly, we're going to consider this generic thing an abstract class, output array of size n, and we know how to create a new one that'll be set to all false, and we know how to set the level at a particular index position 0 to n minus 1 to either true or false. That's what the abstract class is. Our concrete class would be something like output array for a particular length, and we can use those two methods on it. But we also want output array when it's exactly length 8 to have yet another method defined called set from bits from a U8, where it goes through and takes all the bits of the U8. Does anyone know how we're allowed to do this?
Just use 2 different input blocks.
Yeah.
Generic and one of them's not.
Yeah, I had no idea that this worked. So the answer is we can, in general, you can have constraints when you do implementations, including having a specific constant set. So in general, output array is not a trait. It's a structure, a generic structure. So it's still kind of abstract. And in general, when n is just n, we define new and set level. But we can also have a second input block that says specifically when it's 8, you can define this set from bits. And it works great. You can set 8 from bits and it works. And it doesn't just have to be generics. I'll get to that in just a second so I don't lose my place. You can also have trait bounds. There's some lifetimes things you can do. You can have some combinations. Yes?
Yeah, so how do you have something like that not get called if your number isn't?
The compiler will say, I don't know what function you're trying to call. There's no such thing as set from bits on this thing, because this thing has to have a specific length by the time you call it in the code. So
you have to go back and rewrite your code and not.
yeah. I mean, just like, right? I mean, you might have just said something blah blah and you've never defined blah blah. It's the same message you'd get. The compiler doesn't know where you got that name from. It thinks you're crazy that you'd even think that you could call that method.
Does it not give you a hint at all?
I don't know. I have no idea.
It tells you the method doesn't exist.
Yeah, I bet that's all, because it can't. Well, I don't know.
It does say that another implementation has that.
Oh, okay. So that's good. That'll let you go and see what's different. Puzzle 9 got a little small. For device envoy, I want to be able to write kind of arbitrary values to the flash memory. So each block of flash memory, 4K block of flash memory, is going to have a new and a clear method. But if I have a type that is serializable, I also want to be able to save and load that type into a flash block. But if I created a type that's not serializable, then then you can't save them and load into it. Where serializable is two traits or abstract classes on this slide, serialize and deserialize. So how would you go about having this work? Yes, I'm going to do it a different way. So that suggestion was to constrain an implementation to require these traits, which is this idea of what we saw in the previous slide. I'm going to do something different. We'll see what's bad and good about what I'm going to do instead. So first, let's set up something we might want to serialize is Wi-Fi credentials. Our flash block, I'm not going to do the whole flash stuff. I'm just going to make it a hash map from a key into a vector of bytes. And a flash block has an implementation of new and of clear that works all the time. No constraints. And in the same impl block, I'm going to define save, but save is only defined when the thing being saved implements the trait serialize and deserialize to an owned value, and likewise for load. And this does work pretty great. Let me just show you how it works, and then I'll show you how it works in a way that you might not expect and may or may not want. So we're going to create a new flash block. We'll create some credentials. And then we'll, to the flash block, save under the key word Wi-Fi our credentials. So they're saved. Now we're going to take that same flash memory, and we will load the things that we saved under the key Wi-Fi. It might, if it wasn't there, we'll get a none, but if it is there, we'll get some and our value of the credentials type. I'm just going to assume we got it, so we're going to unwrap and then verify that we got our types out of it. So that's great. Let's look what also works. In the same flash block that I've cleared, but nothing else, I can save a 42 as a U8 under the keyword number. Well, that's weird. I thought we were only going to be saving credentials in this flash block, but no, we can save anything in this flash block, any type that's serializable. And even worse, we can load number, but tell it we want to load a string. And this isn't a compiler error. This is fine. When you actually run this right now, you'll get a none value, because when it tries to deserialize 42 as a string, it'll tell that there's something going wrong there, and it turns the error into a none. But that's not guaranteed. It's possible that you, I don't know, wrote out an array of U8s and then asked for a U128, and it thinks that looks all fine, and it would just give you the wrong value. So in the case I'm really using this in Device Envoy, this is what I want. But along with saving the values, I also save some metadata, which is like the name of the type. So at least if you ask for a type with a different name than the type that was stored, it'll promise to give you back none. But that's still not like perfectly guaranteed to be type safe. If you wanted it to be more type safe, you can do what we saw before, which is for each block, make it work with only one type in particular. And that's just a choice you have to make, whether you want the semantics that your flash blocks can only save one type of thing or not. Okay, so this is the final slide. Let's just review what we saw. We saw we could have traits with default methods. We can add multiple levels of traits, like super traits, which let us have like our servo player that could act like a servo. We can have extension traits, which are really just traits that let us add methods to foreign types. When they're common things like clone and debug, there's a nice pre-built macros for us. If we want to be bad and inherit from a concrete type, we can kind of do it using deref. Maybe we shouldn't do that. When we want to make what I kind of think of as extension types, but for all things that would qualify, pass some test, not just the ones you anticipated, then you can do a blanket implementation that we saw before. When nothing else works, and especially if the number of things you want to work with is finite, in my case 15, you can just use macros to make your code as short as possible. With constants or even traits, you can gate an implementation block, so it only so these functions are only defined if the test passes, or even on the method level within an implementation, you can gate them so they only are defined when a particular test. And yeah, as I said at the beginning, what I thought was cool about this is I came into it thinking, oh, here's 9-ish different ways to do inheritance and whatever, and it's going to be hard to remember all the different Rust ways to do it. But there's really only a few concepts we've seen here. And the only things to me that are a little bit tricky is the things having to do with coherence and the rules that don't let you kind of do what you might want to do with a foreign function. And we see the workarounds for that. So any comments or discussion questions? Yeah.
Something I thought of at that last example where you can serialize as one format and then deserialize as a different one. If you wanted to constrain it so that each block could only serialize and deserialize one type, that'd be a good use case for phantom data, which is a type in the standard library, where you can actually store the generic type that you want to use inside that block. But it's not actually being stored, it's just the type name is being stored essentially.
Oh, okay. So Betty suggested that you could use phantom data to actually store the type, not like what I was doing, which was like some hash of the name of the type or something, and that it might be able to get you real true type checking. That's interesting.
It's zero sized as well.
Yeah, and if you did that, it would be zero size. It would just be stuff checked by the compiler.
Thank you, sir.
Oh, one more, and then we'll be done.
There's one other kind of inheritance you can do, which is even more cursed than some of the other ones you've done, which is use the any type and downcast.
Yes, I didn't even think of that. I'll have to
You're
look
a bad influence.
I've never used it. I will look that up. Thank you. Oh, sorry, more?
I did, I'm trying to remember the details now, but you can dynamically cast something and have pointers to the dynamic types for the underlying type, just to fill some amount of traits. I don't know if that would count though as.
Yeah,
I don't know if that would count in your slide set.
Right. I had to kind of limit what I was going to do. So the question or the comment was, there's also this notion, say you wanted, I do something with audio clips in Device Envoy where an audio clip can be a compressed sound, an uncompressed sound, or it can be a tone that's just played algorithmically, or it can be silence. And I want to have an array of those. And you can't have a normal array of different types that all have different sizes, but you can if you use the dynamic types, which adds an indirection, very similar to what C++ does with its vtable stuff. What I like about Rust is I almost never have to do that, whereas my C++ was always doing it, apparently without really needing to. Maybe sometimes the compiler makes it go away. But in here, I only do it when I really do need to have a heterogeneous collection or something. And it turns out in a lot of my use cases, at least, I don't need that. And then everything is called directly with no indirection. So I guess it's faster.
That's type erasure.
Yeah, that's type erasure. Anything else? Okay, done. Thank you.